So we carry on with the chemical properties of alkanes. After combustion reactions, a very important reaction, very important for the mankind. You'll find out substitution reactions of alkane. Substitute, just like football. Somebody goes in and somebody goes out. You substitute a player. Here, substitution of alkanes mean their hydrogens are substituted by, change over by halogen atoms. Suppose in this case chlorine, and the reaction is supported by or carried out by sunlight, in the diffuse sunlight that provide what? UV. Energy provided by UV is utilized in this chemical reaction and substitution occurs. Hydrogens are substituted by chlorine, but the products which are produced are halogen alkanes. We call them haloalkanes, halogen alkanes. Why? Because halogen atom has been incorporated into alkane molecule. It is a chain reaction, carries on until you want to stop it, or the particular product you need, the chemist can switch off the reaction at that time. But what are the products of these reactions? Halogen alkanes. And remember, these are the halogen alkanes which are used as anesthetics, anesthesia. The spinal anesthesia, local anesthesia, or complete anesthesia basically include these halogen alkanes. According to the body weight, the anesthesia specialist adjusts in, but he has the chemical calculation. But products are gifted by those wonderful people, those chemists which have synthesized this. So they set you sleep and do the complicated surgeries, because before that there was no mechanism, like some drugs were given, or sometimes the very harsh men were there to get hold of the patient and carry out all the surgery. But anesthesia sets you to sleep, and when you are up, you are comfortable. Everything has been done, removed. Okay, clear. Remember, what are these reactions? Suppose this is simplest of alkane, methane molecule. Methane because it has 4 hydrogen with a carbon. Substitution occurs one by one. Notice this hydrogen is replaced here by what? Chlorine atom. Now it is chloroalkane, chloromethane. We call it as monochloromethane because one of the chlorine atom is there into the methane molecule. Mono mean one. If reaction goes on, look at the waste product is hydrochloric acid, HCl gas. That is the byproduct, waste product here. If the reaction goes on, chlorine atom molecule will further attack, and one by one another hydrogen is stolen and replaced by chlorine, and we have a halogen atom, 2 halogen atoms into the alkane molecule now, and 2 of the hydrogens are being removed, kicked out, and you have dichloromethane. Di mean 2 chloromethane, and if the reaction is carrying on, supply is there, UV is there intact, third of the hydrogen will be replaced, and you will have this product trichloromethane, very much famous once in the market, trichloromethane, CHCl3. CHCl3, the condensed formula. Why is it famous? Because you may be knowing the name, this what? Chloroform. Chloroform, even used a sort of anesthesia for animals, bit more harsh it is. And then if the reaction carries on, remember halogen atoms are continuously being attacking the hydrogen molecules, and they are being removed one by one, and finally this alkane is left with no hydrogen but 4 chlorine molecule, and you have tetrachloromethane plus an HCl molecule, waste product. So one by one you notice these hydrogens are continuously, practice these equations. Okay, sometimes you are asked to write all the chemical reactions for a particular hydrocarbon involved. It can be any halogen atom here, and will do the same reaction whether it is bromine. Okay, so these halogens are depleting out hydrogen, deleting out, replacing them one by one, and you have monochloro, dichloro, trichloro, and tetrachloromethane along with the waste product. I said these products obtained are halogen alkanes, and they are used as anesthesia. They are used as coolant, like the air conditioner contain haloalkanes, fluorochlorocarbons, chlorofluorocarbons for halogen alkanes, but they have harmful effect. That's why they are replaced these days by chloroalkanes, not fluoroalkanes, not chloro, because chlorine radicals were produced in the upper atmosphere, and they used to damage the ozone layer. Now it is fluoroalkanes rather than chloroalkanes. They are used as coolants. They can be used as flame retardants, especially in aircrafts. They'll put off any fire. Okay, decrease temperature so much quickly. I said flame retardant, and wonderful use another, like this marker contains that anesthetics, and they are used as organic solvents like UHU, glue, etc., and some varnishes and paints and polishes. They contain these organic solvents, even this ink, and they are dangerous. They can cause addiction, worse of the addiction, because that leads to brain damage ultimately. So, but anyhow, they are used as organic solvents. I said halogen alkanes, they are now obtained by reactions of alkanes with what? Halogens catalyzed by sunlight. Sunlight provides in the energy, okay, and then the substitution reaction occurs, free radical substitution. Okay, at this stage you are not supposed to know the mechanism. In your A levels you will know the mechanism, where they will teach you about the free radical substitution. Here you need to now write down equations and the final products. Okay, so halogen alkanes obtain are anesthesia, are coolants, are flame retardants, and are organic solvents. They are used as any alkane molecule they can provide you. Any alkane molecule, like it is butane, C4H10, and the halogen you add yourself. They have given bromine or iodine or fluorine or chlorine. Okay, normally it is bromine or chlorine. So you'll find out one by one, you will replace them. It will be C4H9 now. Where is the 10th hydrogen gone? It is being replaced by halogen atom, and that goes with the other halogen atom, because halogens are attacking the form of diatomic molecule. So that reaction will go on. Halogen alkanes produced have those wonderful uses. Substitution reactions basically are carried out in the presence of diffuse sunlight. Most important reactions, okay, often asked.